All right, so Unit 11, we are talking volume. Volume, we use 3D figures, right? So last unit we did area, which is just the inside of a two-dimensional flat shape. Volume is going to be the inside of a three-dimensional shape. So before we go into volume, I want to just briefly talk about the different solids that we're going to see. So we have really 5 that we're going to look at: prisms, cylinders, pyramids, cones, and spheres. Okay, however, we really probably could classify this with just 2 different types. So if we look at prisms and cylinders, those each have 2 bases, right? And so what I mean by base is there's 2 sides that are parallel to each other. So a cylinder is just a prism with circular bases. So we see that we have, for the prism, we have 1 base, 2 bases, and we have those sides that connect. Same with cylinder, 1 base, 2 bases, and the sides connect. Okay? With a pyramid, right? So pyramids can kind of go with cones, or not kind of, they do go together. Those have 1 base, right? Only that one flat side. So if we look here, we have the circle, and here we have a triangle, but there's nothing else that's parallel to it. Okay, so it has 1 base and the faces meet at a point up there, right? And so again, a cone is just a pyramid with a circular base. We know circles act a little different, so they kind of get their own names for things. And then lastly, there's a sphere, which has no what we're calling bases, and each point is equidistant from a center point. So in all 3 dimensions. Okay, so if we look at the different shapes here, right, we see, let's look at this first one. We see a point, and then we see 1 base. So this would be a rectangular pyramid. I say rectangle because that's the shape of the base, right? So we name them based on the shape of their base. Okay, so if I look at this one in the middle, I see I have one side here that is parallel to this side here, and then I don't have a point like I did with this pyramid. I have these sides that run parallel to each other that connect base to base. So again, the shape of my base is a triangle here. So this would be a triangular prism because we have those 2 bases. 2 bases. Okay, so same with, if I look at this one, I have 1 circle, 2 circles, and then they're connected, right? They don't come to a point. So 2 bases would be a cylinder. Again, really it is a circular prism, but we don't call it that, we call it a cylinder. If I look at this next one, I see 1 base with the sides coming to a point, and the base is circular, so this would really be a circular pyramid, which we call a cone. And then lastly, hopefully this one is easy to recognize. This would be a sphere. Again, no bases, right? Here we would have a center, and each point on that would be equidistant from that center. Okay, so being able to identify the solid that you have is important because we're going to have to know what formula to use. Okay, so getting into 11.1, we're going to look at just the volume of prisms and cylinders. And again, we're grouping these together because cylinders really are just a type of prism. Okay, so important things here. First of all, here is your formula. Big B stands for area of the base. Okay, so that area, all the area formulas that we talked about last unit, you still need to know. Another thing to keep in mind is that this height here, that is from base to base. So it isn't the height of the base, and you'll see what I mean here in a second, but that is the distance that connects one base to the other. So that would be this in that shape, right? This triangle, these two triangles would be my two bases, and then these sides here would be my height. Okay, so if we look at the height, h would be 12, because that's the distance that's connecting base to base. Okay, with a cylinder, basically the same thing. However, if we look at this part of the formula, that pi r squared, that is just really the area of a circle. So because cylinders always have circular bases, we're just making it more specific, right? I could really put that as big B, like we did in the last one, times h, and it would be the same formula as a prism. But again, since cylinders are only circles, we can make it more specific, right? So here would be one base, here would be another base, and then the height connecting base to base. So that, oops, I don't want that. That 12.5 would be the height, because again, it's the distance that connects one base to the other. All right, so let's look at, we're just going to do two examples here together. So this is a cylinder. We see here's our base, and there's another base, right? So cylinder, the volume formula is pi r squared times h, because again, that pi r squared is the area of the circle. So this 4 is giving us this whole distance, right? So that's the diameter. So we need the radius. Remember, we just chopped that in half, so radius would be 2 centimeters. So volume is going to be pi times 2 squared, because that's my radius. And then the height, again, is what connects base to base, so that would be this 10. Okay, so again, when we did circles, we talked about exact answers and approximate answers. So we can leave the pi in there and work on this, the rest of the stuff, and pi kind of acts like a variable, even though it's not. But I can do 2 squared, which is 4, times 10, that gives me 40. So I can say that this volume is really 40 pi. Units, because we're in 3 dimensions, is going to be cubic centimeters. Okay, so this is my exact answer. Sometimes you might be asked for that. And then if I plug that into my calculator and I actually do 40 times pi, I get, let's erase that, I get my approximate answer of 125.7, if we round, square centimeters. Okay, and then, so again, this is my approximate. So if it says round to the nearest whatever, you're going to give this approximate answer. If it says leave answer in terms of pi, you would give this exact answer. Okay, but again, just like area, the hard part here is figuring out what formula to use and then just plugging stuff in. All right, next example, we have finding the volume of this prism. Again, we have, here's our base, it's a triangle, and then the height, again, connecting base to base, that's that 6. Okay, so volume for this is just big B times H. Big B is area of the base. So I'm going to do that over here in a different color. So big B, again, my base is this triangle here. So how do I find the area of a triangle? That's 1/2 base times height. Okay, so of the base, here's my base, here's my height. And this is where things get a little confusing, because this height here is not the height that we plug in here, right? This height is the height of the prism. This is the height of the base. So that's why I like to find my big B off to the side separate so I don't get the two confused. Okay, so I do 1/2 of 12 times 20. And so that would be the same as 10 times 12, which is 120. Now I'm going to take this and plug it in for this big B here. So I get 120 times the height of the prism, which is that 6, because again, that's connecting base to base. So 120 times 6, 720, and again, area is cubic, 3 dimensions, so cubic millimeters, and that is it.